Hello everybody, how are you doing? Nice to see you today. And today we continue our work on vectors. And a new concept is so-called dot product. Dot product of vectors. Uh, Dot product. In Russian tradition we say it a scalar product. And sometimes you can phrase this term in different kind of articles and subject books. And Russian lecturers they use sometimes instead of dot product scalar product. So take this thing into account. If somebody says that it is about scalar product, it's the same thing like about dot product. So dot product is very useful tool to calculate, to define angles between two objects in geometry, in analytical geometry. For example, if you phrase the problem about definition the direction of something, or maybe with the definition of the angles between something, between plane and line, for example, or two lines or two vectors, the very best way, the easiest way to define this angle or define the definition is to define the directions of some objects is to define the dot product. So let's start. Firstly, I give you a definition. If A is a vector with components a1, a2, an, so we have n-dimensional space here, and B is a vector with components b1, b2, etc., bn, the dot product a dot b can be defined as a sum of the multiplication of the corresponding components. I mean a1 times b1 plus a2 times b2. So you have to make this multiplication for all components plus an, bn here. And another one definition, you can define a dot b as a multiplication of their magnitudes, a magnitude, a bar here, b magnitude, times cosine alpha. Here alpha is an angle between vectors a and b by the way, if you define the cosine alpha that is the trigonometry function of the angle, if you remember from your school course, it's the same thing as you find out the angle, because you can calculate very easy this angle alpha if you know cosine of the angle. Or you can use some special tables, or you can use your calculator. So what do I mean about angles between two vectors? I can make here very schematically two vectors, for example vector A, vector B here, and angle between them is an angle alpha. Angle here. Okay, this is the definition. By the way, you can see that we have two formulas for calculation dot product. I want to make this red frame here. Two formulas. And if we calculate the same object, I mean the same dot product, the definition through the components of the vectors and through the magnitudes and angle, they both of these formulas have to give the same result. So the summation of the corresponding coordinates multiplied by each other equal to the magnitudes multiplied by cosine alpha. And this is the basic concept of the calculation of the angles between two vectors. To make it clear, I want to give here some more clearer than we have now. I want to give you some examples. Firstly, examples. So example 1, the easiest one, for example, A equal 1, 2, 3, and vector B equal, I don't know, -1, for example, 0, 5. And we have two subjects to find out. They are, we have to calculate A times B, A dot B, dot product. Unknown is unknown, so I put here question sign. And we have to define angle, an angle between the given vectors. So they are known variable here. So we can use very easy the formulas for dot product. First one, A dot B equal A1 B1 plus AN. I dropped here the some components or some terms of this summation of this sum, and we have here A1. It is 1 times -1 plus 2 times 0 plus 3 times 5. And we have -1 plus 0 plus 15. So it is -1 plus 15, it is 14. That is the scalar product. But on the other hand, A dot B equal magnitudes of the vectors times cosine alpha. Let's calculate magnitudes. Magnitude A, or absolute value here, it is square root from the very first lecture, 1 squared plus 2 squared plus 3 squared, and we have here 1 plus 4 plus 9, and it is square root of 14. And the same thing about vector B, -1 squared plus 0 squared plus 5 squared, and we have 1 plus 0 plus 25, square root of 26 here. So we are ready to use the second formula for dot product, and since that A dot B gives a square root of 14 times square root of 26 and cosine alpha. We don't know the cosine alpha, but this expression equal 14 because we evaluated previously the value of the dot product, and this formula gives you cosine alpha equal 14 over 14, square root of 14 and square root of 26. So this formula gives the angle or trigonometry function of the angle that is likewise to know the angle. So the answer here, we have two answers here. This is 14 is the answer to the question to calculate dot product, and this formula cosine alpha, that is the answer to the question about alpha, gives alpha, that is gives the dot product. Okay, very easy, you can see here. You can notice that A, that is the commutative operation, dot product is a commutative operation. It means that A dot B equal B dot A. What else? Also one example here. You know that cosine alpha equals 0 if alpha equal for example 0. If alpha equal 90 degrees. So if, I mean, it means that if neither alpha nor B is a zero vector, and A dot B equals 0, that means that A is a perpendicular to the B vector. So sometimes you can phrase the verb to check if vector A is perpendicular to the vector B or not. The only one way here, the easiest way, is to calculate dot product. And if the dot product gives you 0, it means that these two vectors are perpendicular vectors. That's all about dot product for a while. Next, our lecture will be dedicated to the cross product. See you later.